Hey guys, in this podcast we talk about different health topics. As we are not medical experts, we'd ask for you to check with your doctor first before using any of the information provided in this podcast. Furthermore, we talk about third-party views in this podcast. Please know that we have no intention of misrepresenting these views, and we apologize in advance if we do so. Thanks. Hey guys, today we're going to be talking about a pretty heavy topic, computers and the future AI. So we're talking like today, 10, 20 years from now as well. And the reason why we want to bring this up is because it's very non-intuitive. A lot of people think, oh, well, yeah, computers, they got smarter, faster. They're pretty cool, but what are they going to do in 10 years? Oh, they'll probably get smarter. Maybe they can do a little bit more cool things. But I want to actually try to convince you that they're going to do much, much more. Actually, much more than you and I are capable of, which is kind of a scary thing to think about. But let's just kind of break down why. And we have to kind of go into a different science of like how the brain works and how robots work, and then we'll be able to extract or figure out like and project what will happen in the future. So the first thing I want to talk about is intelligence. The number of computations that anything intelligent is measured in flops. So what that means is that you have floating operations per second, which stands for flops, and each operation is like 6 times 2, which is
12.
Okay, so 12 that's one operation, and what ends up happening is you end up doing many operations per second. So the brain has about 10 to the 15th operations per second. So one with 15 zeros behind it, which is...
So I should be able to solve math problems better than a calculator. Why
Yes.
can't I?
Yes. Well, because you're using that to understand what you're actually doing. A lot of flops you have are spent on recognizing like what is a 6 and what is a 2, what is a multiplication sign mean.
Yeah.
So only consciously when you have a very small amount left after that. So what I want to talk about today is where computers are. So right now we're like 10 to the 15th. Okay, we call that 1 petaflop, just to make things simple. But the newest Apple products have 7 teraflops. So that's like 3 orders of magnitude less. So 1,000 times less. And that's for like a $5,000 computer of today. So that means for $5,000, your computer is 1,000 times dumber than you are. Okay, which is pretty pathetic, honestly. But within 10 years, if you look at all the different charts, the major consensus is within 10 years, for $1,000, you'll be able to purchase the computational power of a human. Okay, so what that means is that...
No, like a computer seems to target its flops more towards... It can target towards specific things. While a human, you talk about has to understand, like what sits is, have to understand like what multiplication is, all these different things. Are you saying that like at 15,000 flops, a computer can learn like a person can, see the world in the way that a person can?
That is actually the big thing. The thing is, computers are just, the reason why they're like so dumb, like they don't know anything, is because they don't have the computational power to know anything. A lot of things that you are like consciously aware of, like I consciously know I'm in front of a camera right now. I know what a camera is because I recognize it through my visual processing system and all this stuff. That requires at least like 10 to the 14th flops. So like at least 1/10 of your brain power is just dedicated to like understanding what your vision is telling you. You have no idea, like you consciously don't know what your subconscious is doing. And so because of that, we can't really understand like where are computers in relationship to us. It doesn't make much sense to us.
Yeah, because we think like computers, they're smarter, like they can do these huge math problems, but
Yeah.
the computer, that calculator knows nothing about reality.
Right, exactly.
It can't survive on its own,
Right.
anything like that.
Right. So the thing is that the big challenge is that what are you the whole point that I'm trying to get at with all this is ultimately your job, because if a computer can do something that you can do much better and much quicker, why wouldn't they, and much cheap with a lower price tag? What's going to happen with your job in regards to that?
Right, and I think it's also important to mention too that when the computer reaches the intelligence of humans, they will start taking our jobs. But as soon as we are able to make them smarter than we are, then those computers can then go on to make smarter machines than humans are even capable of.
Right.
And so then we see this technology boom of like, computers making computers and stuff, making them more and more intelligent.
Right.
And then that's of course why you have like movies like The Matrix, where
Yeah.
the computers have taken over the world.
Right. So now that's obviously a very dark picture that people are concerned about, but I kind of the reason why I want to bring this up honestly was for the people, like the foundations, like the Bill Gates Foundation. Okay, now I doubt like our podcast would ever get in front of Bill Gates or something like that, but in the rare occasion that it actually would, Here is why I think Bill Gates should spend his 60+ billion in a different way.
Okay, why don't we make the title of this Bill Gates? You should watch this.
Yes, watch this Bill Gates. Yes.
Then,
Yeah, I'm sure I'll get his attention. But here's the thing. I think Bill Gates has very good intentions. I really admire his generosity to identify the diseases that are taking out like thousands by the day in Africa and other poor countries. Africa's obviously kind of, but whatever. So the whole point is that so like what he says is like, let's get them vaccines, things that are so basic here in the U.S. that would cure so many diseases like overnight over there. Clean water is another good example of this, and I fully applaud that. I think that's a great strategy, and there's thousands of other organizations trying to do the exact same thing. But if you think about it, money can only do so much. Like, even if you were able to donate efficiently all $60 billion to this, it still would only last a certain amount of time. Like, you could only deliver a certain amount of vaccines or a certain amount of like clean water facilities there. And hopefully you would hope with that amount of investment, the people in Africa would make their own, they could develop their own nation, cities, and from there build their own clean water.
Do you mind if I'm the devil's advocate real quick?
Yeah, go ahead.
Okay, so the first thing that I'd point out is that the future of computers is somewhat speculation. We can't know with certainty the extent to which computers will go. So first off, you'd have to, in order to make that investment, you'd have to feel very confident in the future of computers, which you very may well be able to feel that confident in.
Mm-hmm.
But we're talking about the future of computers 10 to 15 years from now, correct?
Even 5 to 10, actually.
5 to 10 years from now, okay?
Yeah.
So what do we do about these people with these diseases for the next 5 years? Do we just continue? Don't we need somebody to do that anyway for 5 years?
Yeah, right.
Because these people are going to be in are going to have all these problems, illnesses, and if he invests that over into computers, then they're going to die of these in the next 5 years. Maybe then the computers can save people, but we're not saving the people now. So I think that there's room in our economy for him to help these people, while if technology is so promising, there will be money to put into it to make it what it will become.
Yeah, and I think that's definitely a perspective to consider. But here's my pitch. My pitch is you would actually invest all that money instead in Africa, trying to feed all these poor people, trying to cure all these diseases, which is good. You would actually spend that money in computers and accelerate the timeline. So instead of 5 years, it might be like 2 years, which is a huge improvement. The thing is that once you get an AI, what we call like a smart AI or an AI, an artificial intelligence at a human level, it's all downhill, because straight from that point, they just create smarter AIs. It's no big, like once you get something to human intelligence, you automatically have like trillions of workers at your disposal. Trillions. Like that is, 1,000 times more than every human being on this planet working for your cause.
Yeah. No, and I agree, and that's why I say that it's currently speculation, but if you could know with certainty that your investment would cause this, and I think you can know with confidence, and that's why I think plenty of people will invest in it. But the thing is that there could be unforeseeable roadblocks.
Right. That's
so
true.
we think like you could have a ton of evidence that in 2 years the computer is going to be capable of this, and that. But then all of a sudden you run into one problem. Like maybe there's something that the human brain's just not intelligent enough to put together, and so we never can reach that point where the computer makes it there. So I mean, I think that that's a potentiality, and that's why ultimately the computer future is somewhat speculation. And so to change what we're doing at the present to help people in order to fulfill something that's maybe just speculation, I think that would be the risk that would need to be assessed by Bill Gates.
Yeah, it's definitely a risk, because you don't know anything. And the thing is obviously the risk decreases as time progresses usually.
Yeah.
Like the amount of challenges to get there slowly, diminish, and then finally, when you're at the cusp of it, everyone starts investing in it because they know for sure it's going to work.
Well, you're talking about Bill Gates, who maybe has like $30-40 billion at this point, and if in the foreseeable future computers are capable of this, then don't you think that corporations would all these corporations around the world would invest heavily, because they know if they are the ones to break this, they will have unlimited sources of money. They will make huge profits because they can build a workforce that doesn't need to be paid, that is more capable of things than any human alive is. So, like, I think that, if this stuff is true, shouldn't we see corporations with cumulative amounts of like trillions of dollars invest heavily? And you probably do see that.
And that's actually what you do see. That's why I was going to say that. So basically, if you look at Silicon Valley, if you look at market caps, the number one is Apple. So clearly Google, Apple, Facebook, any high tech Silicon Valley is they're all after this. They are all after human intelligence. Even the government in Europe is. They both made billion-dollar projects to make this happen. So the whole point at this, what I'm trying to get at is that we obviously are in a race. There's definitely a competition here for this goal of.
So it's kind of like the space race, NASA space race.
It's a space race for intelligence, and this perhaps is
like-
the biggest race you will ever see in your life. It is the most important race you'll ever see. Yes, if you land on the moon, that's great. I mean, yeah, you got a guy on the moon. Good job. Okay, but that doesn't really affect your economy that much.
Yeah.
I mean, yeah, like maybe people will be more confident in America or whatever. But the whole point is that when you have intelligence, like if you can keep producing human capable intelligence off the shelf, just like in a factory over and over again, download software in them and they're done. Well, wait a minute. I mean, that's ridiculous.
Yeah.
You're creating something that's just so arbitrary. Like we don't even know how to physically describe it, because the thing is that when you create a product like this microphone, for example, like we visually see the microphone, we know what it does, and that's that. Okay, but when you create a piece of software and hardware together, it's very hard to actually comprehend what it actually is. It's very hard to wrap your mind. It's very hard to wrap your mind and say this computer machine is just as smart as I am. It's really, really hard to understand that. But the point is that if you do, you would recognize A, where the job market is going, and B, why so many people are interested in this, and why actually popular media data is so valuable right now. So like if you look at Facebook, Google, any social network, Twitter, yes, they're making money from ads, obviously, but what they're really going to make money from is from the amount of social data they have. And like how
Well, they currently are making money off of it. Google makes tons of money off of algorithms that they have. Amazon has algorithms to determine like what products you might be interested in.
Right.
They can target those ads at you on different websites. I mean, it's already becoming a major necessity for companies to have to compete in the global environment.
Yeah, exactly. But I'm saying take this a step further. You not only use this data to make targeted ads, but you use this data to train a computer through machine learning. So machine learning is basically the same learning that you and I do. Like we're exposed to like this is for morality. This is a good moral action. This is a bad moral action, and you learn from thousands and thousands of examples what is actually a good thing and what is a bad thing. So the whole point is that in the future, people will use like this social data to understand how humans interact and how humans don't interact, and that's just free data to learn for a machine to learn off of. And if you have billions of interactions of billions of people, that would be the best social AI you could ever get. It would be so socially adept that it could talk to any person and hold a conversation with them, which is also very invaluable for business as well. That's what business is the ability to hold a conversation with another person, given their social background and the deal going down in that. So I guess what I'm trying to say is it's not an economy anymore about product or about material. What instead the economy is about now is information and how information is organized. In the past, it was who could produce the best car, who could make the better house, or who could make the better TV. But I would argue now the job market is so that who can design the better computer, who can program better code, and who can overall communicate and sell this.
Yeah, and I want to add this. This is kind of an interesting thing, but I think what we'll see in the future is we talk about like IQ and EQ, and I think there's something called CQ.
Really, what is that?
So IQ is like your fluid intelligence. EQ is your social skills, like how well you are communicating your ideas, and CQ is your computer intelligence. So when you're sat down at a computer or any piece of technology, your ability to quickly learn what is happening and how to communicate to a computer effectively what you intend. So a programmer has a very high CQ. And someone who's been, and I think that it's becoming more and more important for children growing up to be able to be comfortable communicating with technology.
Yeah.
So technology has a bigger part.
There's kind of a dichotomy, though. I'd say I think a lot of companies are investing in interfaces that are more intuitive to us. So like you don't have to worry about going into the code. Like I think there's now even like a Leap Motion where it's like it can see your hands and your movements, and just from your hands and movements becomes intuitive.
Yeah, and on top of that, like they're building like programming codes that are almost as easy as just writing into the computer what you want to do. You say like, I want you to turn off when someone asks you this question.
Right.
And that's all you have to write. You don't have to do like, tag something, store, like all these symbols that are used in tags to write the programming.
Yeah. Now, one thing I want to get into, and this is so controversial, and I know I'd probably get a lot of criticism for this, but I think it has some validity to it, and I just want to shoot the idea out there, is the common notion of computers versus humans. Like a lot of people say, well, once computers become smarter than us, like what are we gonna do? Like we're killing ourselves if we're basically making something smarter than us. That's eventually just gonna end us. And I actually want to propose to you that you would actually become a computer as well, which is a crazy proposal, but I think it makes a lot of sense when you think about it. So if you look at like a human being, we're actually very susceptible to just being killed if you think about it, or like just being wiped out. Any type of physical disease, like any virus, cancer, bacteria, infection can wipe you out. Any toxic that you get, you're dependent on the air you breathe. You're dependent on any food that you take in. You're dependent on a lot of stable things like the temperature, the humidity, like sensitivity as well. There's all these things that we're very dependent on that other like machine computers just aren't. Like a computer doesn't have to be fed every 10 days or something like that. They only just require electricity and a certain amount of temperature stability. So I guess what I'm trying to argue here is if computers are much better at you, like let's say 15 years, 20 years, if they're much like thousands and thousands of times smarter than you, if they're much more versatile than you, they can survive much easier than you can, then why would you just not use that as your substrate to live in?
Wait, so I think this is an interesting question. So
Yeah.
there's sort of a couple of challenges that came to mind when you said this. So the first thing I'd say is like in our brain we have a very logical and a very emotional side, and the emotional side deals more with social encounters and stuff. Um, and so I think like would you have to, how would you decide which parts of your brain to move? Because if you remove certain parts of your brain, then you wouldn't be the same person. But like if you're still promiscuous, but you're in a robot body,
Yeah.
you can't procreate. And so procreation is the other thing. Is like if we switch into robot bodies, then how can we create more humans?
Yeah, well, I mean, these are questions that I think will be addressed by society.
Do we adopt a robot as a child, or do we
Well, no,
design our
I
own
think
robot?
I think a lot. I mean, I'm saying
And
a
would
huge
we
thing.
be the same? Like if we're putting ourselves in a computer that's much smarter, then we probably like entirely changing who we are. We probably become a different person. And then do we all, because we like we all buy the same intelligence robot to put ourselves in, then aren't we all just the same? We see the world the same. We have the same perspectives. The only thing that would make us different, maybe environmental things.
Yeah.
So
Let me try to address a lot of these issues.
Yeah.
'Cause, one thing I want to put forth. This is like a philosophical thing. So you might know more about this than I do. But imagine like you have I forget. I think it's ship a thesis argument. But imagine you have a ship, okay, and you make a duplicate of it. So you have ship A and ship B. Okay, so you've made a duplicate. All the planks, everything is arranged in the exact same order on the second ship that you've made. Would you say that both ships are the same thing, or are they different?
I would say that they are. I mean, I think it's depends on where you specifically, what you're looking at specifically.
Yeah, exactly.
I mean,
yeah.
if you're talking about, are they grain for grain exactly identical, then yes. But because they're two entities, or not entities, but because they're two separate things, one thing be based on like because they cannot sit in the same position in space, they are in different locations, so therefore they are different. But in terms of specific things, they are exactly the same, but they can't both occupy the same space. So there is some
Yeah.
differences.
So we would
between
agree
them.
that there is some difference. Like,
Yeah.
and plus they're just made out of different, not necessarily different materials, but but the material that made up the first ship is obviously not in the second ship, right?
Yeah,
The
so
material
it's
is
just-
different. Yeah.
yeah.
Now let's reorder the question. A lot of people say no, they're two different ships. They're not the same ship. Okay, but the planks are in the right place, but they're two different ships. Okay. Now let me ask you another question. Suppose you have the old ship, okay, ship A, and you recognize that some of the planks are a little bit off, so you tear those out and you put in new ones. Okay, a couple years pass, some older planks kind of are malfunctioning, so you tear those off, put in new ones. After a century or so, you've torn out all the old planks and replaced them with new ones. Is it still the same ship?
Well, I don't think it's the same ship to begin with. So I think that there's things that are similar about it. But I would say that no, it's not the same ship. It never was the same ship. But I think that maybe it develops more of a personal identity as it changes.
Yeah. So the point I'm trying to strive at is what makes each person unique is not the material that it is made up of, but rather the order that the material is placed in. So the planks kind of represent your neurons in your brain and different chemicals. And your neurons do get old, and they have to be replaced usually by more neurons. Now, your brain can't usually make these new neurons, so you end up becoming old and you can't
and
process.
like your heart and your kidneys and all these things, they rebuild
Yeah, they rebuild.
over your lifetime. So there is a philosophical question here, and it's kind of like if our body is rebuilding ourselves every like 7 years or so, are we the same person?
Right.
Each rebuild, and This would get into whether dualism is true, because in order for us to be the same person, dualism has to be true. Because if we are just material, then we are a different person then. If the ships are just material and there's nothing more to them,
Can you
then they're
explain that a
suddenly
little bit better
different
for everyone who doesn't know?
Oh, which one?
The dualism. And,
Oh yeah, I was
how
going to
that
get into.
relates.
So materialism is just essentially the hypothesis that we are just the combinations of chemicals and material, and people often who are materialists or naturalists who say that the physical laws of the universe have created us through pure material. There's been no interference from any outside source. There's no soul. Or things that metaphysical realm does not really exist. It's all just material.
Yeah.
A dualist believes that we have physical bodies that are made from material, but there is a soul to us. There's something more, a metaphysical existence. So the analogy that's often used is a piano player playing a piano. So the piano is like the material body. In order for the piano player to communicate his music through the piano piano cannot be broken. It has to function properly. So like when we see like a broken piano, the piano player can no longer communicate through it. So something like Alzheimer's or something.
Yeah.
When suddenly you can no longer communicate. So we see something beyond this. And there's different arguments to why this is probably the case. I think the strongest one is the evolutionary argument. It's naturalism, but I want to do that in a separate podcast.
Yeah.
But there's reasons to believe in dualism, and more philosophers are becoming dualists. And so what I'm saying is that the reason why we are still the same person 15 years after our body's material has completely changed is because we have a soul. And that soul stays, as it does evolve and grow and mature, but it stays static. It's always been you from the day you've been born. And so just because your material changes doesn't mean you're a different person. And that's one of the reasons why I think that we actually feel like we're the same person, but that our experiences have shaped us to think differently about things.
Yeah.
And so that would be the thing. Like the ships, yeah, they're different if you're just evaluating them on the basis of material.
Right.
But when you throw in something like, like a soul that the ship has or something, that's when I think you could talk about it still being the same ship even with different material.
Yeah. So I'm not saying I believe in materialism or anything like that, but I just want to say that a lot of people that propose this usually believe in materialism. Like they don't believe there's a soul attached to it. And that's obviously another debate.
But I also don't think it's necessary to, like, I think that it's evident that we have a material body, okay, that is reproducible in technology, but we can't see whether or not we have a soul. And so I think you can believe that computers are capable of becoming a intelligent being without saying that we don't have a soul. So I don't think it's necessarily follows that in order to believe in computer technology and its capabilities that you have to be a materialist.
Oh, okay.
I just think it's maybe it could be a more common belief.
Yeah, correlation maybe.
Correlational. Yeah.
So anyways, to kind of close the argument out. So basically what they're saying is instead of replacing your brain, like your brain can't replace itself with neurons. There's a certain limit. And as you get older, there are a lot of other reasons why that doesn't work as well. But one hypothesis is to replace certain parts with computer chips, because computer chips use electronic signals just like your neurons do.
Yeah, and it's currently being done.
And it's currently being done, yeah. And like in Parkinson's patients, for example, a lot of them have difficulty controlling like their movements of their hands and their joints. And the thing is that they can actually help control those movements with electrical stimulation from embedded computer chips within their brain. And the result is just amazing. Like you can wirelessly turn off the computer chip, and then they'll be vibrating, shaking, violently. And then you turn it back on, and they're just fine. Like they can hold a cup of coffee and just like drink it, and have no problem.
Yeah,
with
it's
it.
incredible. Yeah.
And then the part that blew me away though was like their software updates. Like they constantly get updated, like with the newest version, which makes it even better. Like they can hold a coffee cup even better.
So I think what we'd see then, like if we start the implementation of bringing computers into the human body to improve functionality, I think we'd see it, be a progression, an evolution of, starting from just small regions of the brain, making improvements, software updates to extend on to like bigger regions. Like
exactly. Yeah. I think it'd be a step-by-step progression as well. Like maybe one thing happens and then another thing happens. It's kind of like the smartphone thing. Like maybe a couple people have it first. They're like the nerds of us all, and then eventually more people get it, and then everyone has it.
And then this will increase at an exponential rate.
Yeah.
And like one thing that's interesting technology-wise is that companies are building like eye contacts that you can put in your eye, and you can open computer screens and manipulate the data on them. You can zoom in on things, zoom out,
right.
And you can like operate your computer with your eyes. So you can imagine like having a conversation and pulling up a computer screen.
Right.
Like people on Jeopardy would probably be cheating.
Yeah. So the whole point is that whether it's like computing like with your eyes or like I guess there's like these smartwatches or something. I mean, the whole point is I think it's a step-by-step progression of melding computer with man. I mean, I just think it's going to become like that. And I think it's not necessarily a bad thing. It's actually here to help us. Like there are devices where, if your pancreas is not working because of you have diabetes, for example, there are devices that literally substitute the function of a pancreas, and it really helps diabetic patients. Like it's a very trust me, they will tell you, like instead of like injecting like their insulin every certain amount of time, the whole device monitors their blood and injects the appropriate amount, so they're not getting like this huge level of insulin and then like getting another huge level. They're instead getting a constant level like they're supposed to. And I think these little things I think will go a very long way into helping us. Honestly, I think a lot of people are like, well, I don't want to become a machine, and you'll obviously have the choice.
Well, I think that a lot of young people wouldn't want to be a machine. Though.
Yeah,
but like
when you're 85,
like a lot of people talk about how bad old age is because you lose functionality of like muscles. You can't go on runs anymore. Yeah. And so at that age, it makes a lot of sense to convert because you can suddenly do stuff.
Right.
Again.
I just want you to imagine like, I don't know, Lord of the Rings or something, where all, each elf is like, they look like they're 25, but they're really like 900 years old. That is what I think things will be like.
Yeah, I think, the thing is, I think a lot of people don't want to live that long. Like, people don't. Yeah, people, even with the age of, like 85 or 75 on average or something, like, people don't want to live that long. So, 900 years is a long time, but maybe it's so we don't want to live that long because we don't want to see other people die and see our family, like, lose our family and lose our functionality. So maybe we eliminate that aspect to it, and then I think we have to look at like how we control the population with people living this long and things like that.
Right, that's
like
a big
sort
issue.
of I think another problem that arises is a society that is completely built on the wealthy control. Like the wealthy, just they're able to buy these computer chips.
Yeah,
and they're able to live forever and accumulate more and more and more, and then people who just can't get into it.
Yeah, I mean, basically, yeah. I mean, here's the thing. I think a lot of people commonly say to me, like, I wouldn't want to live to be, like, 150. Like, that's too long. And maybe that may be. But I think when you're 85 and you're thinking that, you're right. You're, like, you're living in, like, a nursing home. Yeah. And you're not doing what you did when you were 25.
Yeah, so, like right now, if you could live yeah, I think you're almost saying that
if you're 25, always 25.
And you don't want to live, like, if you're 85, but you're staying at 25, you're basically saying that you don't want to live at the moment, like, at 25 years old.
Exactly. Like, if you don't want to live, like, from 25 to 35, then you wouldn't be here watching this right now, right? Yeah. So the whole point is that if you're 85, but really you're 25, then you would be in the same predicament where you still want to live, right? Like, I mean, so I know it's kind of like mind-bending to think about that stuff, but imagine like the president being 25, okay? Imagine like, Bill Gates or any, Steve Jobs is still around and he's 25 and he's doing fine, Yeah,
well, I think that one thing, though, that we'd have to look at is sort of the philosophy of death itself, though, because, like, let's say people are living to be 900, but you murder someone.
Oh my gosh!
Like, imagine that
the death or like
the death penalty.
Life in jail forever. That would be terrible.
Yeah, and like so, there's a lot of things that would have. But yeah, like you murder someone and they just missed out on like 899 years of their life.
Yeah, it's a big thing, and like so.
And then everyone else has to live another 900 years without seeing them.
Right. A common thing that you and I have talked about in other podcasts is like you can't distinguish someone from the rich versus like the middle class today. Like if someone had $1 billion versus $50,000, from looks alone, you could not distinguish who was who.
And like in 1900s, if you went into a room with a billionaire and a bunch of lower class people, it'd be easy to pick out who's the billionaire. But nowadays, you can have these big seminars that have billionaires like all over the place, and you wouldn't be able to point them out.
Exactly.
They're all wearing suits, and they're not suits that look all that much better. I mean, maybe they're wearing brand name suits that are incredibly expensive, but you can't tell because now the off-brand suits look just as good.
Yeah, exactly. So I want to actually challenge that now, and I'm going to say that's going to change. Because the people who look younger will be richer. The people who will invest the money in all these computer and reverse aging technologies. We'll do a podcast on like organ development and 3D printing new organs and stuff like that. The whole point I want to come across is that it may be that the ultimate goal is to be 25 forever, and because when you are 25, you don't want to die. Mm-hmm. And actually, that's kind of like the goal of medicine as well. I mean, it is to get you to the health of a 25-year-old.
Yeah, I think another goal of medicine is to, which we assume death will happen, so it's to make it so that we have the most capabilities up until we die.
Right. So, a lot of people are like, how is the world going to sustain that economy? I mean, Obviously, I think by then we'd be going to other planets, and then because we're all 25, we can work, right?
We don't have to work though because we have all these robots
Yeah,
that do work
exactly,
for us.
exactly. Yeah.
Yeah, it's very interesting, and I've talked about this before, but this is why like I think fiction has pragmatic, practical value is
Yeah.
because in fiction we explore these possibilities of future worlds and explore that what could arise from them. Like we've discussed some of the stuff that could happen, but a fiction book just goes deeper and like tries to live out a scenario where where the world changes in a slight way.
Yeah.
So I think that we can actually, if we want to know more about this stuff, then read science fiction because
Yeah.
science fiction attempts to really explore what will happen if these changes occur and when they occur.
Right. We don't have that much time left, so I want to finish with one last thought, just
Okay.
for like my personal opinion, and obviously get other people's opinions. I just want to touch on the jobs of the future. Like if you're kind of like in high school right now, trying to figure out like, well, I want to have a job like when I'm like 25, or 30. The basic thing, in my opinion, is that jobs won't exist in mechanical, low-skill jobs. So I'm not trying to say that. I'm not trying to say that basically like the jobs of like frying a burger is like worthless. It's not. It was necessary for the time that it existed in. But I think basically most minimum wage jobs that repeat the same thing over and over again are very susceptible to like
Yeah,
computer.
and I don't think that people are that afraid of this because I think that those are the worst jobs to have.
Right.
Mechanical labor is hard. Sitting at a desk is not hard.
Yeah, exactly.
And doing something that you're skilled at is not hard.
Right.
So these are jobs that we want to be eliminated.
Yeah. So I would say like but most minimum wage jobs are mechanical jobs, like where you're doing the same thing over and over
Yeah.
again. But I would say certain sectors of the economy are very good to go into. So like for example, like any health related job is probably a good idea because let's face it, we're still going to have problems. We're not going to cure cancer, tomorrow. So I think any health related job is a good sector to go into. I think any law sector is a very good sector to go into because no matter how smart computers are, humans will always want to have the final command over things. And I think politics and how law functions will always be a good thing. I think computer programming itself is a good field. It's a growing field to go into.
Yeah.
I think that.
And on this note, like I'd like to say that like right now I'm working on HTML programming, which is really easy. I'm just trying to make sure I have the basics down. And I'm also in JavaScript, and there's some websites on the internet that are just phenomenal at teaching this stuff.
I think Khan Academy.
Khan Academy is good, but there's even websites that are more user interactive, like where they tell you what to type in, they let you try to solve it, and if you can't solve it, they show you what to do.
Yeah.
So you can learn these programming languages very quickly. Like don't be intimidated by the fact that most programmers have been programming since a small age. Programming languages will get easier, and then they'll become easier to learn. But if you get yourself into it now, then you can sort of set a foundation to learn more later. So I recommend learning programming languages not only for the future jobs that are available, but also because it's a good experience to learn programming because it teaches you a lot about the process of mastering a skill and problem solving.
Right. Two other fields I want to put in as well is like any engineering field. I think designing things is always going to be necessary. I don't think we're going to like tell a computer to design like a 90-story building and just leave it up to it and just walk away. So I think there'll be always like an architect and a
Well, yeah, and ultimately, if these computers can take away these intelligent jobs, then no one will have jobs, and it will be great for everyone because we can just chill on beaches in Florida.
Well,
because these machines will do the stuff for us and make stuff incredibly cheap.
Right, but I think the dangerous part is the transition part because some of us will have jobs and some of us won't.
Yeah, but that's always the case with technological improvements. Like when you see, like going from the manufacturing era to the technology era, there's tons of people who lost their jobs. It's just an evolution of an economy.
Right.
And it's a stage that you go through. And if you're having trouble, then so is everyone else around you.
Yeah, that's true.
So,
and finally, the other sector I wanted to just talk about was the social, like any social sector. So, for example, like Paul is like a business entrepreneurial student, which I don't think is going to be taken by a computer anytime soon.
Well, an entrepreneur can't because it's a pretty ambiguous job.
Yeah, exactly.
Yeah.
And the art of social interaction, even if a computer masters it, which I have no doubt it will, I'm sure it will, I still think people are going to want to talk to other people about serious issues, like a deal going down or like a contractual agreement that they're arriving at. I think there are different formalities behind that. They take them out to a nice dinner usually. They have like a long discussion. And I think that type of social interaction won't be replaced by computers in the near future. So I think those are like the major sectors that I would hit on personally. But I just want to share this. I know there's a lot of controversial stuff we shared about it. It's not all complete facts, obviously. But we'd love to hear your thoughts about it. Comment below.
Yeah, and subscribe to our video. If you watch all the way through, at this point, you need to subscribe. You really like our stuff, obviously.
So, all right. Thanks, guys. Appreciate it.
Adios.